Hi everyone, this is your Cisco trainer and welcome you to lecture number 5 from the course CCNA 200-301. In today's lecture, I will cover the following topics. All today's lecture will be cover different aspects of Ethernet switching. How packet goes from the LAN, from the same LAN from one computer to another computer, how PC A want to send frame to PC 2 on same LAN. So it is 100% completely free courses to pass the CCNA exam 200-301. And if you like the video, leave a comment, share to help us spread this free series of videos. And if you haven't subscribed to my channel, stay tuned please by just clicking on subscribe button, thumbs up, hit the bells icon, and do not miss the upcoming notification and alerts. Now let's jump and start it. OSI model, physical layer. Why I reviewed the OSI model lecture from the lecture number 3? Because Ethernet switching or packet switching in the same LAN, it is involved with two layers of the OSI model layer. With the layer 1 physical layers and with the layer 2 data link layers. So physical layer define physical characteristics of mediums used to transfer data between devices. Voltage level, maximum transmissions distance, which is limited to 100 meters. Physical connectors, cable specifications. Digital bits are converted into electrical for wired connections or radio for wireless connections. All of the information in lecture 3's video, cable, pin layouts is related to the physical layer. OSI model data link layer. What's the functionality of data link layer? Data link layer provides end-to-end connections, router to switch, switch to switch, PC to switch, or router to routers. In this diagram, I will hope you gain enough information about what does mean end-to-end connections. So in this diagram, I'll show you. PC A wants to send data to router B sends data to router E, and router E sends data to client F. So it is called end-to-end connections. There's all computers, routers, and switch are involved when they are sending data. So this is the responsibility of data link layer. And also data link layer responsibility is detect and correct possible physical layer errors. When two computers try to send the data, if in two ends, computer A want to send data, but computer C want to receive the data. If there is an error, so it is the job and responsibility or the functionality of data link layer if something occur in a bit. So it is the rule and the function of data link layer to detect it and correct it, then pass data to other owns. Data link layer use layer 2 addressing. Layer 2 addressing is different from the layer 3 addressing. Layer 3 addresses IP version 4 addresses, IP version 6. These two addresses are called layer 3 address, but layer 2 address is called a MAC address, or physical address is called layer 2 addressing. Switch operate at layer 2 of the OSI model. That is why I reviewed lecture 3 data link layer and OSI model layer from the lecture 3 of this course, because switch a layer 2 device is operate at layer 2 of the OSI model. What is local area network or LANs? How do we define a local area networks? There's lots of definitions and illustration on a network, on LANs. In here we have a LAN. What is LAN? One or two more computers which are connected in the same segments and they share data between each other, that is called LAN. So in here, how many LAN do we have? We have 3 LAN in here. Switch is a single device which provide connections between the computer's node hosts. So it is called a LAN. Routers does not make a LAN. Router, each interface of the router is provide a one LAN. So in here we have 3 routers that are connected via a cloud. So each interface of the router is connected to a separate LAN. We have LAN 1. So in here we have 6 computers. 3 of them is connect with the switch 1 and 3 of them is connect with the switch 2. So it means we have a LAN. When we expand the switch, so a switch will make huge the network, the LAN. So the router is connect with the switch, so it is a one LAN. In the other hands, we have a second LAN. We have 3 types, 3 LAN, sorry. LAN 1 with the green colors, and LAN 2 blue, and also the other is a LAN green. So we have 3 LANs. Each LAN are separate from the others. So in today's lecture we will cover how PC1 try to pass data in a LAN 2 to PC3. So these are in the same LAN. It is the functionality of Ethernet switching, but in the future we will have a separate video how to pass packet frame or how to pass frame from one LAN to another one. It's a separate video, but in today's we will talk about how to pass data from one computer to other computer in the same LAN. So LAN is a combination of computers in order to send data from one computer to other computer or share the data resource, that's called LAN. What is PDU? And how to define PDUs? So the first segment, the first data is encapsulated from the top 3 layer of the OSI model layer. That's called segment. What do we have inside the segment? We have a packet. And what do we have inside the packet? The data is called frame. And what do we have inside the frame? And the data is called bit. Or in other words, we can say L3 data is called bit, L2 data is called frame, L3 data is called segment packets, and L4 data is called segment. These combinations with the header file of layer 1, layer 2, layer 3, and layer 4. A complete this encapsulation is called PDUs, or packet protocol data units. When the top layer try to encapsulate the data, they process the data is called a data. But later the layer 4 header is added. This is called segment. And then layer 3 header is added. Now it is called frame. And the end, layer 2 trailer and layer 2 header is added, and this combination is called bit. So when the computer is processed, so the computer process a data with the combination of different layers headers. This combination of packets data on layer header of the layer, that is called a PDU, or protocol data units. So Ethernet frame, what do we have in Ethernet frames? In the left hand side we have Ethernet header, and on the right hand side we have Ethernet trailers. So what is inside the Ethernet header? And inside the Ethernet header we have 5 separate fields. The first one is preamble, the second one is SFD, destination address, source address, type, or length. Ethernet trailers are CRC or FCS. Preamble and SFD is used in order to make or provide synchronizations between the source and destination of the computer. So preamble is a 7 bits of address. It's time to 7 is a 56-bit address. SFD is a 1 bit. Sometimes they are combined together. In some book, the teachers or the others write a preamble is an 8-bit address because they already combined SFD with them. What does mean SFD? Start of frame delimiter. So the Second, the third step is a destination address. It's a 6-bit address. It is a MAC address and source address type or length. What is CRC or FCS? FCS means frame check sequence or frame checksum. SRC is the algorithm which is used by the FCS in order to detect error. Cyclic redundancy check. Ethernet frame and SFP, preamble and SFP. Preamble length is 7 byte, which is equal to 56 bits in binary, alternating zeros and 1. So the format of the preamble is 1010101 times 27. It's equal to 56 bits. It allows device to synchronize their receiver clocks. SFD, a start frame delimiter. Sometimes it is a start of frame delimiter. Length in 1 bit is equal to 8 bits. But the last bit is always set to 1. 10101011 marks the end of the preamble and the beginning of the rest of the frame. Destination and source. What's destination and source? Digital device which send and receiving the frame indicates source and destination. Consists of the destination and source media access control list. What is media access control list? It is a physical address. MAC addresses consists of 2 parts. OUI, Organization Unique Identifier, is a 24 bits, and the rest 24 bits a vendor assigned to each different devices. In the globe, we cannot able to find 2 same address with the computers, so it is different. Each computer has separate and completely different from other computers and MAC address. MAC address a 6 byte, which is equal to 48-bit address. MAC address a physical address. Type or length. What is type or length? The last field of the Ethernet frame. Length is a 2-byte field which indicate the length of the entire Ethernet frame or the encapsulation of the frame. This 16-bit field can hold the length value 0s to 65534, but length cannot be longer than 5000 because of some own limitation of Ethernet. Indicates the length of the encapsulation packet in bytes. A value 1500 or greater than 65534, and the field indicates the type of the encapsulation packet like IPv4 and IPv6 address. So if the packet is, the value is greater than 1500, so it means it indicates the encapsulation packets like IPv4 or IPv6. Frame check sequence. So it's a review of Ethernet IEEE 802.3 frame Ethernets. Header, Ethernet, headers, packet, Ethernet, trailer. Preamble is a 7-bit. SFD, a start frame delimiter, is 1 byte. Destination address is hex byte, which is equal to 48 bits in binary. Source address is also equivalent to destination address. It's also a 6 byte, which is equivalent to 48 bits in binary. Data is 46 or 1500 bytes. Type of the data is a 2 bytes. Now CRC and FCS. Let's check what do we have inside the CRC and FCS. FCS, it is called frame check sequence, sometimes called frame checksum. FCS is a 4 byte, which is equal to 32 bits in length. The last field is CRC, which is used to detect the error. When something's happened, FCS is used. The algorithms called CRC. CRC is used in order to detect the errors and make it correct. CRC means cyclic redundancy check. What is MAC address? The actual MAC address is same as that I have in here for you guys. So MAC address as 6 byte address, which is equal to 48 bits in binaries. A0 48 1C 06 03 B3. MAC addresses combination of hexadecimal numbers. So burnt in address BIA. Sometimes MAC address is called burn in address or abbreviated as a BIA. It is a globally unique. Consists of two parts. The first part is OUI, Organization Unique Identifier. It is the first 3 bytes of the MAC address is called OUI, which is equal to 24 bits. And the vendor assigns the last 3 bytes of the MAC address is called a vendor assigned, which is different each computer from each others. Organizationally unique identifier. Address format hexadecimal characters. So the address format of a MAC address is based on hexadecimal number. We have we have 4 types of address. But in the CCNA class, we only discover 2 or 3 of them. The first one is binary, the value which is base 2, and there is also there is only 2 values, 0s and 1. The second is a decimal system number, which indicate 10 values from 0 to 9, and the third one is hexadecimal number, which indicate 0 to 9 A to F. So this is the format of hexadecimal number. Decimal numbers. The decimal number system is said to have base 10 because it is used 10 digits from 0 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. A decimal numbers start from 0 to a millions. So it is the decimal number format. We start from 0 up to 9. But when we say 10, we just shift. We use the shift value of the numbers. We shift 0s and 1. Then we shift 1 with 1. Then we shift 1 with 2. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and so on. Hexadecimal number system format. The hexadecimal number system is said to have base 16 because it is used as 16 digits from 0 to 15. Hexadecimal number is a start from 0, 1, 2, 3, 4, 5, 6, 7, 8. We don't have 10 in here. So instead of 10 we use A, B, C, D, E, F. So A is equivalent to 10, B is equivalent to 11, C is equivalent to 12, D is equivalent to 13, E is equivalent to 14, and F is equivalent to 15, and a lot more. So in a hexadecimal, we have 16, 17, and so on. But after 10, we use A, B, C, D, and till to F. From A to 7. So this is the format of hexadecimal number. That is why I mentioned to you, because the MAC address is based on hexadecimal number. Internet Protocol version 2 is based on version 4 is based on decimal number, or this dotted decimal. MAC address packet switching. How these computers send frame to other computers. So I have here 4 computers, each one have a separate MAC, a different MAC address when was switch. PC1 MAC is AAA BBB AB01. PC2 is AAA BBB AB02. PC3 AAA BBB AB03. And PC4 finally AAA BBB AB04. With switch 1, each port of the switches connect to different clients or computer. Now when the computers A or computer 1 try to send data to computer 4 or frames to computer 4, first it sent a unicast, unknown unicast message to the switch. So switch is looking to the packet. The packet is combined with destinations and source address. The destination address is PC4 and the source address is PC1. So PC1 tried to send data to PC4. So And here the switch doesn't have information about the rest of the clients. The switch just only know about the PC1 because it already earned the MAC address on the interface. PC1 is connect to fast Ethernet 04 and its MAC address is AB01. I haven't write all of the MAC address because of the lack of space. So that's why I just mentioned about the last portion of the MAC address to the frame. Now the switch send it over to other computers. So this type of packet is called unknown unicast address. So unknown unicast addresses, so switch doesn't have information about the rest of the clients. In this case, switches flood the packets. Switch flood the frames to the other computers. Now the switch, this kinds of earning information about the switch is called dynamically learned MAC address because the switch doesn't have information about the switch. First, switch sent flood the packet to the all other clients except the interface they received the packets. So now PC2 drop the packets, PC3 drop the packets, only PC4 process the packet up to OSI model reference. So once again, PC1 try to communicate with the others because switch haven't information about the rest of the clients. Packets sent from PC1. Switch now again, because they don't know where the packet should go, again they flood the frames. It's sent to the rest of computers except the port which the switch received the frame from the computer once. Again, switch computers 2 drop the packet, computers 3 drop the packets also, but the only PC4's process and it forward the packet back to the PC1s. Keep in mind, when PC4 reply or forward to the PC1, the format of the source and destination is reversed. So this is called non-unicast or forwarded. Now PC4 send data to the switch. Now switch learned the address or the MAC address of the PC4 and send data to the PC1. Now in MAC address, in a MAC table of the switch, there we have 2 MAC address and also 2 interface. AB01 is belong to PC1 and AB02 is belong to PC4. Now this is the information which sent in a same LAN between the computers. How the switch process the packets or the frame between different computer in a same LAN. So thank you for watching. That is all about today's lecture. If you want to show your support, please subscribe the channel, like the video, leave a comment and share video with anyone else studying for